The next presentation we have coming up is a live presentation with Mike Walker and myself. So Mike, WA3MW, are you there? Hopefully.
I'm here. I'm waiting for Rod to unvideo me. Here we come.
Excellent. All right. We'll let you out of the green room into the light of day here.
But I can hear you just fine.
Okay, so let me go ahead and set this up as we're getting the video switching figured out. So this presentation is a presentation that Mike and I put together, and we were talking about the idea of station automation and remote station operation and how that's becoming kind of a bigger deal these days. And so we wanted to approach this from the standpoint of projects that you could build and also other gadgetry that you can add to your station to do remote control or even local automation inside your shack. So I'm going to go ahead and start this with a couple of framing slides to give you an idea of what we mean by this. And then we'll go into some examples about the components that you could use to automate your station. So let's start out with a definition here. What is station automation? And really there's a couple different applications. One is remote control. In other words, the idea that your radio is in one location and you're in a different location. And of course, in the traditional sense, that is where your station is perhaps in a different city or in a different country or somewhere really far away. The other thing to think about is even around your own station, you might have your radio in one room and you might be operating from a different room, or even inside your shack, if everything was in one spot, you might want to be able to control stuff at the press of a button as opposed to a bunch of individual actions you might want to take. So some of the things you'd want to be able to do, of course, is work the radio remotely, but you also need to think about the physical world around it. So the ability to turn power supplies on and off, switch antennas, take temperature measurements of your PA, whatever might be useful. And these kind of ideas really make it easier to operate your station in the sense at the press of a button. And there's also applications where you might want to do 10 things at once and simplify that with a single press of a button. The classic example, of course, is antenna sequencing when you're doing things like satellites or EME, where pressing the PTT button requires a bunch of relay operations to turn off preamplifiers, switch from the receiver to the transmitter, then key the transmitter without anything going bad. So that's another example of automation that you could consider doing. So what's really changing, I think, in the world today, as opposed to, let's say, 20, 30 years ago, is there's really a sort of a confluence of really interesting factors that make this not only possible, but make it very practical for a lot more of us than it used to be. So one of the things that's really a kind of a change is the notion of having a radio that's remote controllable. And that started happening really 20 years ago, where you started to see radios with serial ports that allowed us to use computers to control the radio. And now we see the evolution of radios that are really designed more as RF servers. And we see that from multiple vendors these days. And Mike's going to talk a bit more about that idea. The other thing, of course, is the computer in the shack. 20 years ago, the question might have been, do you have a computer in the shack? And these days, it would be very odd not to have a computer in the shack. So the ubiquitous computers everywhere. The availability of microcontrollers and embedded Linux systems like Arduinos and Raspberry Pis, those are much more accessible to us, and the hardware that sits around it is very readily available and very inexpensive. Obviously, the internet plays a role in this as well, because if you're physically remoting stuff, you need some way to communicate across between your control point and your station. So the internet and cellular telephones and even private point-to-point data networks, like putting in your own private point-to-point 5 gig Wi-Fi, control channel might be just the thing for you. So a variety of communication channels. And lastly, if you want to build your own hardware, the availability of inexpensive PCB fabrication companies and the availability of free software, so you can design your own boards and have them fabricated. So all these really add up to kind of a golden age of homebrew and the ability to design and construct your own station automation projects. So in this, the rest of this presentation, we're going to talk about a few of the components in more detail. So Mike's going to touch on radio architectures, I'm going to talk about a couple of hardware projects that I worked on. And another topic that's not on the agenda here, Mike's going to talk a bit about an interesting topic, which is the practicality of doing CW keying over the internet and how that's a challenge. And lastly, I'm going to share a little bit about using some commercial control panels like the Elgato Streamdeck to control gear in your shack. So Mike, let me go ahead and hand it over to you. And why don't you go ahead and touch a little bit on the remote radio idea.
Thanks, George. You know, and as I was sitting here thinking while you were talking about that, if we took, you know, the space shuttle and the control console for the space shuttle, and then looked at the control console in SpaceX, we're headed the same way. You know, we love our buttons, but, you know, I thought, geez, I have more monitors in my ham shack than the SpaceX guys had, right? I'm sure you've noticed that, but maybe I have a problem. But anyway, so we talked about this within Ham Radio Workbench a couple of times, but and yes, I do work for Flex, and yes, this is a bit of a commercial, but it's also a bit of reality because I'm a pretty active amateur radio operator as well. I do contesting and remoting. I started back in 2005. Excuse me. I inhaled wrong. The radios we have now were designed to do this from the ground up. They have full HF operation from the core. You don't need a VPN, all these things that we had to do in our early days. We can have two people using the same radio, and I guess it's a simple matter of software, not that I'm pre-announcing anything, but we probably could have 4, 8, or 16 if it was big enough. And we're starting to get rid of the RS-232 port. And that's 60, 70-year-old technology. And while it's really useful and incredibly reliable, it's really single-threaded where only one person can use it. Now we have multiple ways to access a radio to get on the air, whether it's Smart SDR, which is the Windows client for accessing the radio. You can use it on your Mac, your iPhone, your Maestro. You could write your own because the radios coming out of the Flex are designed actually to have, or they're wide open. So if you want access to the audio, the push to talk, I want to change my filters, I want the waterfall, I want the pan adapter to this, you can do it because we use the same tools for the Smart SDR software, but that doesn't prevent somebody from writing it for, I don't know, Linux, Android, Chromebook, or whatever else comes out. Next slide, please. So this is sort of the quick view. Now we have a radio sitting in the bottom right. It's either in front of me, maybe it's at the base of the tower. I tell you what, Cat 6 or 5 cables a lot cheaper than 4 runs of LMR 400 or better. And it's also, you know, just sort of the way we're heading. And I've done that with my remote where I'm getting further and further away. Now I have fortunate to have a cottage, and when I'm at my cottage, I am actually sitting in the main cottage, but all the radio equipment's 500 yards away in a boathouse. So yeah, there are times when I've gone, geez, I wonder what's going on over there. And George touched on it when he said, imagine any button you have now in your ham shack. Like if you saw the picture I posted on the Facebook channel, I have monitor and I got monitors and I've got shelves in between, but those shelves are going to go away because I do not need those in front of me anymore. They can go behind me. So that's going to change as we go through there. We can run digital modes. We can have 2 of us running different digital modes at the same time. And in the Flex design, we actually just share a transmitter. It's not the matter of a main receiver and a sub receiver like we probably have used in most radios. Now we have all these main receivers that can see the entire HF spectrum at the same time, like a web page. Like if multiple people are looking at different pages on a web page, well, now we can do it with the HF radio spectrum. And we don't have this problem with RS-232 conflicts. Like in earlier days, I could either run my logbook, but if I wanted to use N1MM or FLDigi or WSJT, I had to shut that down and do something else. Yes, we could get away with virtual serial port or VSPs, virtual serial port control, and they do work. They're not necessarily plug and play, and if you have a good command of how RS-232 works, you won't have an issue. But in today's world, the list is getting a little shorter. Next slide, please, George. And I think this one's yours.
Yeah, so let's describe a little bit about what a station could look like. So in this case here, this is kind of as Mike and I were talking on the Workbench podcast about coming up with how do you do remote station design and what are the parts that you need. This is kind of a typical illustration. And in fact, this is my station looks like this with a radio, of course, at the, kind of the center of it. a PC, and then a bunch of hardware that sits around it in order to do the right kind of control and monitoring. So what I want to talk about are a couple of projects that I worked on that kind of augment this station. So in this case, the radio and the software that goes with the radio handles the remote radio control itself and the piping of audio. So that's kind of a solved problem. But if you're remote from your station, you don't necessarily want to leave the station on all the time. Or maybe when the station's on, you might want to switch antennas or rotate the antenna or whatever. So you need some external stuff beyond the radio to make that all work right. So in this diagram here, what you can see is a couple of control boxes in the yellow. So what I call the GPIO controller, or general purpose IO controller. That was a little project I'll show you in a moment. And then also some antenna relays. In my station, I have a single HF antenna, but I have multiple HF radios, and I want to be able to switch between the different radios at the push of a button if I'm sitting here locally. And for VHF and UHF for 6 and 2 meters, I have multiple antennas. I have horizontal antennas and I have vertical antennas. So I want to be able to switch those antennas on a single radio, as well as being able to turn the power on and off on the station. So let me show you what these projects look like in more detail. What I'm going to show you are some projects that I recently finished and made some prototypes, and I'm using one in my station today, and I sent one to Mike, and he integrated it with some software. So the next talk, by the way, this afternoon, Mike's going to talk about using a software development environment called Node-RED, which is a nice graphical programming environment that lets you do essentially automation software control pretty easily. And after I sent Mike my GPIO controller prototype, he worked on the Node-RED code to make it work. So he's now controlling the box through Node-RED. So be sure to take a look at that talk as well. So this box is really intended to do a variety of things. There is an Arduino microcontroller in it as the brain. There's 8 dry contact relays for digital inputs that are optically isolated. There's 4 DC voltmeters that are referenced to station ground. There's 2 additional differential voltmeters, which means you can measure a voltage without measuring it against the system ground. They're floating, which is very handy, by the way, if you're doing something like measuring the voltage of 2 12-volt batteries in series, because you need 28 volts for something. You can measure the 2 batteries because they're not referenced to the real ground. You can also do temperature measurements with a digital temperature sensor. The thing runs on 12 volts. And we communicate with it through 2 different options, either through RS-485 or through a data radio using simple ASCII control commands. The reason for RS-485 is because unlike RS-232, RS-485 is what's called a multi-drop network. In other words, I can hook up as many devices as I want on the 2 RS-485 wires. And this is a technique they've been using for 30 years in industrial automation when you want to hook up physical devices in your fabrication plant. So, it's a fairly old technology, but works really, really well over particularly very long distances. Or you can use a little digital data radio to transmit the information. This is a view of the prototype version from the top. So what you can see here is all the connections are brought out to pluggable headers. And then the Arduino is the black circuit board on the left. So this uses an 8-bit Arduino Mega processor. So it's got a lot of memory and a lot of I/O. And you can see the little relays on the left. And then in the middle is the opto-isolator and bridge rectifiers that isolate the digital inputs and allow you to put in the inputs either direction, so you don't have to worry about getting them in the right orientation. On the far right, you can see the little blue plug-in module says XB. That's the 2.4 gig data radio. And the little blue board above that is a 2-channel differential ADC, analog to digital converter, which you can plug in as a separate module. So also, by the way, one big safety tip is don't use linear regulators on something like this. Use a little switcher. So the tiny little green circuit board in the upper left-hand corner is a 5-volt 1-amp switching power supply, which allows you to shove 13.8 volts into this, and it'll never get warm. If you put in a traditional 7805 linear regulator, it'll get hot. So go with a switcher. So to control this thing, I came up with a ASCII command protocol that allows you to send a set of ASCII text in the clear, you can plug in a dumb terminal on your PC and just type commands to it, or you can write a program, or you can get a piece of hardware that generates those ASCII sequences and transmit that to the board.
Oh, like Node-RED.
What's that? Or Node-RED.
Like Node-RED, or your Streamdeck.
I have a feeling we're gonna come back to see that in a minute. So here's some companion boards that also work in the same system. So part of this whole concept, by the way, is to be able to build different kinds of controller hardware, but that can all talk on the same network. So in addition to one or more of those little GPIO boards, you could have antenna relays. And so here's inside my shack, I have 3 antenna relay boards. The top one is my 4-to-1 antenna relay board for the HF antenna going to 4 radios. And then below that in the black boxes are UHF and VHF coax relays that are single pole double throw to select 2 antennas to 1 radio. So the nice thing about this approach is whether the antenna switching is at your tower or in your garage or across the country or under the desk, you just have to flick a button. It'll send a command to the boxes and they'll switch state. And I find that just super, super convenient. This is what the inside of the VHF one looks like. When you're doing something like this for HF, when you're doing this for HF, the relays are not, yes, you're laughing at me, Mike. The relays are not critical because it's very low frequency, but at VHF, the relays are super important. So you need to use impedance controlled relays. So these Tohatsu RF relays are really necessary. So if you'd like more information on those projects, we're going to be talking about that in a lot more detail on the Ham Radio Workbench podcast. And we'll probably make those boards available as build projects if people want them. So we've done that in the past with other projects where we put out the circuit board and publish the schematic and the bill of materials, and you can go source the parts yourself and just get the circuit board and build your own antenna relays and other projects. So Mike, why don't you go ahead and talk a little bit about doing remote control with CW?
Thanks, George. I actually wanted to mention RS-485. If you're worried about it or you think that's freaky, it's just RS-232, but it's long haul. It's a bit more to it than that, but in some ski racing stuff I've done, we've used RS-485 to go 7 kilometers. So instead of what the spec is in RS-232, George, 9 feet, something like that?
Yeah.
I think it is actually. It's like 3
meters. It's like 25 feet. They're 50 feet, yeah.
So
which it's only 2 wires, point,
so.
Which makes it useless. So yeah, this is much better.
So we get this call quite a bit. I want to send CW over the internet. And in the Flex world, you have to have a Maestro. You plug a key in the back of a Maestro. That's an $1,100 solution. So it's probably out of the budget for some people. But if you're a hand-sending CW person, it works beautifully. Remote Rig as well has this built in. They use the same technology we use. They probably came up with it first. But I thought about this one day. So, well, how hard can it be? I just need to grab, the dash side or the DIT side, or just level, RTS on the CW or on the RS-232 port and have it toggle the transmitter on and off, and I'll get some audio feedback somehow and be good to go. Well, yeah, sure. Technically, that works beautifully as long as you don't want to send more than about 1 word per minute. And I think it's the next slide. I'll show you why. So I did this, by the way, these graphs I put together yesterday afternoon in Node-RED in about a nanosecond. We'll show you in the next talk how that works. On the bottom middle is the only 2 I really have available is pings. And what I was looking for is jitter. And jitter is the variance in the delay time from here to the other end. It varies quite a bit, actually. And in order to send CW, we need an absolutely perfect, incredibly low latency of maybe a couple of milliseconds and no jitter. That means no delay. It always has to get there 3.5 milliseconds from now, 3.5 milliseconds. But on a LAN, that's impossible. Things slow down, they speed up. And on the bottom one graph is ping taken every 1 second or 2.5 seconds to my router. It's in the other room. But even then, look at that. We had a 10 millisecond delay. In fact, it was even longer. Why? Don't know. Could be other traffic on the LAN. Some packets got dropped. But this is a great indication of why the LAN is really good for watching Netflix, but really bad at times, and even more so on the the WAN side, the world side, when using it for HF radio, because we get annoyed if it's more than maybe 200. So let's look at the screen, the graph on the top right. I'm pinging the remote router. It's 160 kilometers away, and we can see, I usually see about a 25 to 30 millisecond ping time, but it varies all over the place. And that started at what, 136 yesterday? That's just a minute. And we see how much it varies, and it can be as long as 50 seconds, as low as 25 seconds. So the jitter in that case is about 25 milliseconds of jitter. Now imagine trying to send CW with a key, just by toggling the dot and dash, in a logic shifting mode. Not really practical. We look at the radio, which is on the other side of the router, and it even gets a little worse. And those extra delays are because of other traffic flowing through the router. And it's busy doing its thing, and it's juggling some traffic here and there. And our jitter is, let's say, from about 30 milliseconds to 75 milliseconds. And, let's 50 plus milliseconds of jitter. It's just not going to work. So how do we get around it? And we should have probably done a slide in this, and I don't think we did. We actually use WinKeyers that are built in to sending CW, and there is a group, we'll have to make this available, George, that have done a remote WinKeyer implementation to make this work. So there we go.
So with a remote WinKeyer, you can apply that to any radio, right? That doesn't really, it's not unique to any one brand or anything.
Great. There's our 10-minute warning in case you missed it.
Okay. So I want to touch on one other thing before we go to the questions. So one of the things that I showed in the shack diagram is using some common control surfaces. So these are products that are not made for ham radio. These are really made for other computer applications. And there's a whole bunch of products out in the world like this. One of the most famous ones is made by a company called Elgato. They have a product called a Streamdeck, and that comes in various different sizes. Basically, it's a keypad, and you press a button and it does something. And normally these are used to control things like your video editor or your audio software, or things like that, where you want to have a tactile kind of control over the software. But I wanted to apply this to the shack. So here's a picture of what the shack looks like. So up on the screen it's a flex radio showing the spectral display, and then below that's an Elecraft radio, and then there's some other radios, and they're all controllable from this one Streamdeck, actually. So there you see the box in the middle with the lit up buttons. That's the Streamdeck sitting on the desk, and this thing comes in 3 different sizes. There's like small, medium, and large, and they do the exact same thing, just with more buttons. The thing that's quite amazing is the key tops are little tiny backlit LCD displays. So when you program what these buttons do, you can also put a graphic image on the button to represent what the function is, and that could be text or it could be a picture. So it's pretty cool, and the software is very easy to use. So you can create a whole hierarchy of menus. Is the way I set mine up. At the very top level, I have a button that then either can select a bunch of different antenna relays. Remember the box with the antenna relays? All of those relays are controlled from buttons, and it's hard to see in the diagram here, but down in the bottom on the left-hand side, that little row of buttons at the bottom, each one of the antenna buttons has a picture of the antenna itself. So, why not? So when you want the 6-meter loop, there's a little picture of a 6-meter loop, and you just press the button and it makes the relay click. So that's really handy. Then I have other submenus that change various operating conditions for CW or sideband. That's just the way I decided to organize the stuff. So there's the main launching pad, and then it'll control the various devices. So if I kind of go back to the beginning here of the station diagram, what's actually happening, there we go. What's actually happening is you see the Streamdeck on the left-hand side. When you press a button, that launches a little tiny program that sends an ASCII control code out one of the COM ports of the PC. And that goes over that RS-485 cable to all the devices. So the command goes to the 3 antenna relays, and it goes to the GPIO controller. And depending on which device I'm sending the command to with an address, it will accept the command and then do the task, turn on a relay or read a voltage and send it back to the PC software. So this is very, very simple to set up. If anybody wants to do this, I can show you how to program the Streamdeck. It's super easy. And even just the little shell program that sends the control codes is very simple. You can install that in a minute and then control various devices. So in the next talk, when Mike talks about how to use Node-RED, we'll be using a similar approach to that. So those are a bunch of ideas we wanted to run through and give you some thoughts about how you might do some station automation. So with that, Rod, I want to open it up and see if there's any questions.
Yeah, very good. Let's have a look at one from Andrew, who said, anyone deal with a remote controlling, simple, inexpensive version of using FM mobile radios remotely?
Oh yeah, we've been doing that for years. Actually, we've done at repeater sites. We've had remotely controlled base stations at repeater sites. So in our network, we have mostly UHF repeaters, and we do have in some sites 2-meter remote bases. And you know, in the old days, they were crystal controlled, so you'd select the channel with a relay, and then they became like commercial radios, like Centaurs, were programmable, sort of programmable, and again, you'd select them by channel. And nowadays, of course, you'd use a serial programmed radio, but that means you have to use an amateur class radio, so it kind of depends on the quality. For doing it at home, it's pretty straightforward. Since most of the modern ones, like let's say an ICOM 705 for sure, or a older 706, or an ICOM 7100 or 7200, any of those could be easily, well, 7200 is not VHF, but any of those radios with VHF, you could certainly do that with. Mike, do you have any thoughts?
No, I think you touched on it because I know how we did it. But yes, I think if we had to do it today, we would do it a whole lot differently.
Yeah, I think the missing link to there that's not in what the answer we gave is like, well, what would you put in the middle? And there's not a good commercial off-the-shelf solution to that, partly because most of the VHF, UHF radios are not externally controllable. So I would say today that the two practical approaches is you either go with a commercial radio, like we've used things like Motorola CDM 1500 series radios, where you program, let's say, 5 channels in it, and you bring out the mode pins to the back, and you can ground different pins. Will let you remotely select channels. So now you just need a way to ground a pin. And you could do that with some combination of things like what Mike's going to talk about with Node-RED, if you want to control it from your phone remotely. In our repeater control systems that we build, you can do that with DTMF. So you can DTMF control a radio. That's another option. So I mean, there's many ways to approach it. With more modern radios with serial ports, it's a little bit easier if you have a controller that supports that. And a lot of the commercial controllers do.
Yeah, there's also a comment in the chat about using the Kenwood V71, which is quite affordable because of the support for CAT commands. So very good. Hey, what about K7AGE?
Hey, Randy.
About, hey, I need this GPIO box. When is it available?
Oh, great question. So I made a prototype version, built one, sent it to Mike, and then I built another one myself, and a second version with had a few improvements in it. So I think the design's done, and I have a bunch of other projects I got to get out of the way, but I would say in the near future. So if you're interested, shoot me a note and then we'll talk.
Oh, very good. I don't see any other questions in there. Anything jump to mind, Mike?
No, it's been a blast. I've done this for a long time, and it's gotten easier and easier, and more stuff gets ripped out. And I think, Rod, you've seen pictures and pictures. And the Node-RED, I'll show you where I went to version 4 to version 5 of the remote ham shack. And I think I got to thank George, who got me down a lot of this thinking a long time ago when I was doing so much repeater control work. It's just the same, but different.
Yeah, a lot of the concepts are very similar. And, you know, like I was saying earlier, I think one of the most exciting things about this is there's so many things that you can do now that are relatively inexpensive. I'll throw out another thought, which is out of the ham radio world, there's a lot of controllable devices and internet resources. There's a system or service called If Then Then That, IFTTT, that's kind of a hub that lets you bring together a variety of control points and devices So you could use that sort of thing for shack automation. The typical radios, amplifiers, a lot of accessories are remotely controllable these days, and pulling it all together actually, that's in a way, that's where the work is right now. The devices are ready to go, but you need to have that central control point to kind of make it all work together.
Right. Vince put up a question, and I was going to, sorry, I jumped on you, Rod. I'm going to answer that.
Hey, that's my job.
That's your job.
Hey, question from Patrick about sending CW to a remote flex without using a Maestro.
Yeah, you'll have to look to really do it well. You can use a CW keyboard, and that's probably not what you want to do. So you can look at the remote WinKeyer thing, and if you want me to send that to you, you can fire any one of us an email. Send me an email at work, my call sign WA3MW at flexradio.com, and I'll get you the link for that.
Very good. Hey, question for George from Mark from Smitty. Can you run power over a 475 cable?
Over, I don't know what a 475.
485. It's a typo.
Oh,
yeah.
Oh,
Okay.
it's the down rev version of the 485.
485, yes.
Okay, so let me take a step back and a quick note on what does 485 look like physically. So 485 defines the electrical interface. So in other words, the number of wires and the voltage for signaling. There are two wires. They're cleverly called the A wire and the B wire. And what happens is the sending device puts a voltage across the A and B. It's what's called a differential pair. There's a voltage produced across the two wires. It's not referenced to ground. This is how they get the very long distances and some decent noise immunity. So the 485 wiring is a half duplex system. So only one device should be talking at a time. So let's say, for example, you have the PC and you have a device. So the PC's COM port has to go through a little USB to 485 dongle that you can buy for like 10 bucks on eBay. Now you have the two wire twisted pair, the A and B wires. Then at the device end, like in the case of the GPIO box, just screws into the box because the 485 interface is built into it. So every time you send a character like A from the PC, that ASCII value gets sent across the wire to the destination. And you can have as many devices hanging off that AB wire pair as you like, but only one can talk at a time. Okay, so that's the data part of it. So you need two wires, twisted pair. It's not super critical. They're not impedance controlled or anything. So when you go to a factory floor, they'll run 3,000 feet of bell wire to do RS-485. It's very typical. Okay. Now, separately, you can say, well, if I have a remote device and I want to power it, is there a way I can use that in conjunction with 485? There's no industry standard for this. However, the way I designed that little board, you'll see there's an RJ45 jack on it. So there's an 8-pin modular jack. The pins 1 and pin 2 of that modular jack are assigned to be data A and data B. So now I've got 6 pins left over. So what would you do with 6 extra pins? And the answer is put power on it. So I just stole the idea from power over Ethernet. Now, PoE is 48 volts, more or less. And we don't use that in ham radio. So I just use it for 12 volts. So pins 4 and 5 are connected together for the positive side, and pins 7 and 8 are connected together for the negative side. So I'm using 4 of those 6 unused pins for power. So by using 2 wires for power, you get a little bit extra current capacity, a little bit less voltage drop. So so that's the way I designed the system, so that the 485 connection could either be literally a twisted pair screwed into a terminal block, or it could be carried over a piece of Cat5 cable. So that way, with one cable drop, you can take data and power from a master to a device at the other end. So that's no industry standard. I use the same pinouts as PoE typically. There's an industry convention, but not a standard for that. By the way, I've seen it reversed. Be careful. But yeah, you can certainly. So the way this device is built, yes, Mark, it'll support both data and power over a single Cat5 cable.
So a couple of questions, I think, directed more to Mike, but to both of you really, is what's been your biggest challenge in setting all this up, the technical challenge, and also if you had to do it brand new all over again and not have the path that you've been on, what would you do differently?
First one's the internet, hugely unreliable. Second one is in part of Park 1 is no Wi-Fi, even more unreliable. And as anybody who's ever worked on internet or whatever knows, it's easy to get it to work. It takes some work to get it to work well, and some thought. So that was always the biggest challenge. And my first ever outage when I was away for the winter was the internet went offline, and I called the cable company and I said, "What's wrong with my modem?" And they said, "Oh, we pushed out some new firmware. Just unplug it and plug it back in, and it'll reset and you'll be good to go." And so put a Christmas tree timer on that. That was back in 2005. So the modem would reboot every 24 hours, around 3 in the morning. I still during the winter do that even today with a lot of things. I just reboot it just in case it gets hung up. It'll recover. It's saved a couple of road trips. One as recently as yesterday when I was trying to fine tune some rules on the firewall. Do over? I don't know. That's a good question. I'm not sure where that came from because it's been an education starting from day one. If I had time travel, yeah, there's a lot of things I would do over, but it's been a very fun education on to get this working and reliable. And I immediately understood how AMSAT felt when they launched a satellite, or the guy on the Mars rover. You can't just reach out and push the reset button on the motherboard. So I don't think I have a good answer for that because I've just done it over when it needed it as new technology came out. In the early days, it was Ham Radio Deluxe, a PC8HN, Skype, and a TS480, and that worked. I was a static, terrible radio for what I was doing, but I was on the air in a quiet area, and then it just got better.
So definitely the unintentional consequences of distance, right? Where you make one little change. It was just such a small change, and all of a sudden you've got a 4-hour drive.
Well, every repeater owner knows that story really well.
No
you
kidding.
Get to the bottom of the hill and you go, you know what? The receiver's a little low. I should go back up there and twist the pot. 3 hours later. I just throw out just to add to what Mike said to that particular question. What you see in this diagram is me doing it all over. So you're actually looking at it live here. So I think the first thing that struck me was the new generation of radios that are really radio servers. I think Flex really led the charge there, and they're really kind of in the lead. Spending a lot of time with folks from Elecraft are doing the same thing. So I think you're going to see that more and more. So a lot of the other manufacturers haven't quite gotten there yet. They're good at remote control, but they haven't completely separated the control point from the RF deck. And I think that's kind of the trend. So I think we'll see more and more of that. So I would if I wasn't focused on the cost, let's start with that, then I think some of these nicer high-end radios are really the way to start. If I was very cost conscious, then I would go with a radio that's serial controllable, and there's tons of those radios out there. I think the ICOM 7100 is a fantastic example because you've got every HF band and VHF and UHF to boot, and it's all remotable. So I think there's a lot of great radio options. And then for the rest of
that's why I haven't sold my 7100 yet.
Oh, really?
Yeah.
Yeah, that's good for that purpose. And then I think what you'll start to see is more and more project boards like what we're doing. So, things like these antenna relay boards, the GPIO board, stuff like that. I think, we'll just see more people doing that stuff. The work that, Mike, you're doing with the Node Red guys that we'll see in the next talk, I think is kind of really the big missing link. And so to really pull all this stuff off, what you really need is like what a surprise. You need a lot of people with different expertise who can all contribute a component to the solution. And I think you're going to start to see those kind of things becoming much more common. And I think what's driving a lot of this is you can remote stuff so you want to, but a lot of us are in conditions where we may not be able to put up an HF antenna. We live in an apartment or a retirement community or whatever. And so, you can't put up an antenna. What are you going to do? So there's a lot of reasons that are motivating people to try to figure out how to do this.
You're going to see, I'm doing a talk next week for Hemcation, and I've titled it "The Death of the RS-232 Port." I can't wait.
but not the RS-485 port.
No,
Anything
485
else?
is good.
Anything else there, Rod, before we go to the
No,
next?
I think that's just winds it up. I'd like to thank you guys for a great set of Q&A.
All right, great. Thanks a lot,
Thanks,
Mike.
Rod.
We'll see you after the drawing break. So I'm going to hand it over to John and Marcel for the next drawing.